We're now going to look at question 4, which was taken from the February-March 2012 DBE examination. I don't know which question it was in there. But anyway, so what we have here is we have a group of learners, so it's a experiment type question, that use the reaction between zinc, oops, I should have a pen there, shall I not? No, there we go, pen, that has zinc and sulfuric acid to investigate one of the factors that affect the reaction rate. The equation below represents the reaction that takes place. So we have zinc plus H2SO4 goes to zinc sulfate plus hydrogen gas. Then they say to you, we add 6,5 grams of zinc granules to excess dilute sulfuric acid. The dilute isn't as important as the fact right now as the fact is that they said excess. They are telling you straight away that it is the zinc that's the limiting reactant, okay? All the zinc's going to get used up and there'll be sulfuric acid left over. And then they measure the mass of zinc used per unit time. So they would put it in an open beaker on a scale and the gas escapes and that tells me how much mass of the zinc is used. The learners then repeat the experiment using excess, again, concentrated sulfuric acid. So what have they done? They've looked at what happens to the concentration, okay? Looked at what happens to the concentration of the H2SO4. That's the factor they changed. First question is to define the term reaction rate. It's a definition. So that's straightforward. And yes, in this particular reaction, we were looking at the change in mass, but they didn't ask for this reaction. They just said in general. So for 4.1, we would say it is the change in concentration, should be the rate of change of concentration. Let's just change that quickly. It's the rate of change in concentration or of concentration of reactants or products. You could have also said rate of change is telling me it's per unit time. So you could have also said, that's a bad pen, change in concentration of reactants or products, but now because it's a rate per unit time. Okay, perfect. Next question. Why must the acid be in excess? Well, we just spoke about that, okay? Because we want to make sure that the zinc is the limiting reactant. Okay, so why must it be in excess? To ensure all the zinc is used up. Okay, Zn is the limiting reactant. That's what we're looking for, okay? Great. Write down a hypothesis. Now, here's why I made such a deal out of the dilute and the concentration. Concentrated, because my hypothesis is what do we think the conclusion's going to be? All right, and we are looking at reaction rate and concentration. Basically, we're saying, do you understand how reaction rate and concentration work together? Well, a good hypothesis would be the reaction rate, there we go, the reaction rate increases with an increase in the concentration of the H2SO4. So I'm being specific as to what concentration I'm changing. All right. Next, give a reason why the learners must use the same amount of zinc granules in both experiments. Well, surely if I use different amounts of zinc, I'm going to get different amounts of product. And it's possible that maybe the amount of zinc affects the rate. Okay, it's not going to, but maybe it does. So why? Because it is a control variable. We can only change one thing at a time. Great. Now we get the fun part of these, and that's the calculation. So the results obtained for the reaction using dilute sulfuric acid are represented in the graph below. Great. Using the graph, calculate the mass of zinc used from 0 seconds to 60 seconds. Look here. At 0 seconds, we had 0.1 moles of zinc. At 60 seconds, we have 0.08 moles. They want mass. First, I need to know how many moles were used. This was my initial number of moles. This is my final number of moles. I need to know how many moles were used. So, I know, so this is 4.5. My initial number of moles was 0.08. My final number of moles, sorry, I'm lying to you, was 0.1. That's 0.08. So that means the number of moles used is going to be 0.1 minus 0.08. But I wanted mass. Now we go back to what we know about stoichiometry, in that N equals M over M. So that's 0.02. We want the mass. The mass of zinc is 65. We get that off our periodic table. 1.3 grams. That's not so bad. But why did we need that? Because now they say calculate the average rate of the reaction in grams per second during the first 60 seconds. Well, we can only do average rate, okay? Average rate means that I need to take, so we're doing the average rate, and it's the mass of the zinc used divided by time. 1.3 divided by 60, and that gives me 0.02 grams per second. Don't forget the units, just to carry down of that. We could have done it in moles, and then we would have got 0.02 divided by 60, but they were specific. They wanted grams per second, which is why we asked you to calculate 4.5. Last question. They say, copy the above graph into your answer book, and on the same set of axes, use a dotted line to show the curve that will be obtained when concentrated sulfuric acid is used. Label the curve P. First of all, when I do a question like this, and this is the important thing because this is what you guys forget. Oh, that's a bit thick, so let's not use that. I think we're going to use this. I need my original. That was my original graph. I need time. And this is amount of zinc. They didn't want any values. But then they said draw a dotted line to show the curve when we use concentrated sulfuric acid. That means it's going to go faster. I want a line that does that. Must be steeper, and I label that P. Make sure we can see it. Okay, if I can't see it, then I can't give you marks for it. Okay, very